Hi everybody. This is the last section of 1.1. We're going to look at the last topic in this unit. We're also going to be working on reviewing as you have a quiz coming up. So let's take a look at yesterday's assignment. The last assignments you got, you had this question number 136, and it was about surveying. So go ahead and get that out, and let's take a look at how this is set up. One student in a surveying class measures an angle as 74.25 degrees, while another student measures the same angle as 74 degrees 20 minutes. Find the difference between these measurements, both to the nearest minute and to the nearest hundredth of a degree. So this is a good application problem for the practice problems that we've been working on so far. And you can see that there is the angle that was measured from the outside of this house between the trees. Okay, so what I'm going to do is I'm going to write down the different measurements that both students got. So one student had 74.25 degrees, and the other student had 74 degrees 20 minutes. And the question is asking you to find the difference between these measurements, both in minutes and then also in hundredths of a degree. So I'm going to start by changing this exact measurement of 74 degrees 20 minutes into a decimal. And I do that by bringing out the full degrees, and I'm going to bring out the part of a degree. So that's going to be the 20 minutes. If you remember from the last assignment, 1 degree is equal to 60 minutes. So if I want to figure out what part of a degree this is, all I have to do is take that number and divide by 60. So I'm going to go ahead and go to the calculator, and I'm going to type in 20 divided by 60. And then I'm going to go ahead and round that to the thousandths place, just like we did in the assignment. So I'm going to round that to 0.333. So I'm going to write the 0.333 here, and I'm going to bring down the 74 full degrees. So this is 74.333. Okay, next what I'm going to do is I'm going to go ahead and take this decimal answer, and I'm going to find it to the nearest minute. And actually, after reviewing the directions again here, it says the nearest hundredth of a degree. So hundredths would be 0.33, so I don't even need this extra 3 here. That would be thousandths place. The directions say nearest hundredth, so I can just go with the 0.33. And that's right here from the directions. Nearest hundredth of a degree. Okay, the other thing I need to do is take this decimal approximation, and it says round it to the nearest minute. So I'm going to bring out the whole degrees. I'm going to bring out the part of a degree, which is the 0.25. And rather than divide by 60, I'm going to go ahead and multiply. So these were the questions where we did the opposite of what you did over here. These are the ones where I'm trying to get rid of the fraction, or the decimal, I'm sorry. So I'm going to go ahead and multiply by 60 minutes. This will tell me how many minutes I have in this degree. So I have my calculator here, and I'm going to type in that 0.25 times 60 to figure out how many minutes I'm dealing with here. And you'll see that I have 15 minutes with no decimals, so that means 15 minutes exactly. If this was 15 and like a 0.8 or point something, that would mean you have seconds. But this example even says to the nearest minute. So this would be 15 minutes. Okay, so what you have then is 74 degrees and 15 minutes. The question then says to compare the difference of these two measurements. So find the difference between these measurements. In other words, compare them. So we can compare this one to the original. It was originally 74 degrees 20 minutes. That's what the one student got. And we just calculated this measurement that the other student got and found out that it would be 74 degrees 15 minutes. So pretty close, actually. When you're talking about minutes in an angle, you're talking about a really small amount. So if you were to subtract these two out, the difference between the two students' measurements would be 5 degrees, or 5 minutes. So that's actually a pretty accurate measurement that they got. If you were to compare the other two forms of the measurement. This student said, oh no, that's 74.25. And we just calculated it and we got 74.33. And if you wanted to take the difference of that, you would subtract the bigger number minus the smallest. So actually this 0.33 should probably be on top if you want to be technical with that. And I'm going to go ahead and type that into the calculator. So I'm going to put in the 74.33 minus the 74.25. And you will see that it's 0.08 of a difference between the two measurements. So the last part of this unit is talking about coterminal angles. So go ahead and write down the title to this section, coterminal angles, and then go ahead and put the date so that you can organize your notes better. So go ahead and put today's date on this line. So what is a coterminal angle? So after you have the title and the date written down, you could just kind of put your pen or pencil down for a moment. And I'm going to show you what the definition of a coterminal angle is. It is an angle that has a complete rotation of a ray that measures 360 degrees. So if you think about a circle, a full rotation from one point around a circle to the other is a rotation of 360 degrees. So when we are talking about coterminal angles, these are angles that are sitting in the same position, but you have rotated around several times. So once or twice or many times. So for example, if I'm again, you don't have to write this down. If I'm talking about this angle right here, if you start at 0 and you rotate up counterclockwise, that gives you a 60-degree angle. Now, if you continue that rotation around 360 degrees, you now have the same angle, but it sits at 420 degrees. If you rotate again, you could again add the 360. Your answer is sitting in the same position, but now you are talking about an angle that is 780, and so on. And you can continue rotating around and around and around. All of these angles with this measure, 60, 420, 780, and so on, are considered coterminal because their angle actually sits in the same position, but it depends on how many times you've rotated in order to name it. Here's another example. You've got an angle that's 110. If you were to go from here up to here, it's 110. But as you rotate around a full rotation, you would add 360 degrees to that. And then you could rotate again and add 360 degrees to that and add 360 again and again. And all of those values that you get when you add in those 360 will be considered coterminal angles. Okay, so what we're going to do is we're going to find the angle of least positive measure. So definitely write this down. This will be your portion of the notes for today. So write down the title, write down the example, pause if needed, and we're going to find the measure of least positive measure, the angle of least positive measure. Okay, so what we have here is a really big angle. And when you're working with trigonometry, you don't want to work with angles that are gigantic if not necessary. So what I'm going to do instead is find an angle that is coterminal with this. In other words, 360 degrees away from it. We are looking for a positive angle. So that means we want to subtract, but we want it to stay positive. Okay, so we're going to keep subtracting 360. And we're going to go until we find the smallest positive angle. So this would be a good time to go to your calculator and type this in. Okay, so my first answer is 548 degrees. And what I'm trying to do is I'm trying to find the lowest positive answer that I can before going negative. So I believe that I can continue to subtract. So I'm going to try to subtract another 360. And a 360 degree subtraction is just one rotation around the circle. Okay, so I'm going to go ahead and try again. And I'm going to write this down every time, by the way, as I go. Okay, so I have 188. So I'm going to go ahead and write minus 360. And I still have a positive answer, which is 188 degrees. Okay, now I'm going to try again. So what I'm looking for is the least positive measure of an angle that's coterminal with us. So I'm going to go ahead and try one more time. 188 minus 360. And take a look at what happens. You end up with a negative angle. So I'm going to stop where I was at 188, and I'm going to say that 188 is my angle of least positive measure. If I was to graph this, you would start here at the initial side over here, and you would rotate around counterclockwise. Okay, so here's what you're going to learn. Straight up and down will be 90. All the way over here will be 180. And so your angle is just a little bit past this. And don't worry, we're going to learn how to do this as you learn how to graph these angles. Okay, so this is 188 degrees. But if you rotate around a full circle, then this would also be known as this 548. If you were to rotate around again, it would be known as 908, and so on. Okay, but we're not really looking for these other angles. What we're looking for is the least positive measure so that it can be graphed and so we can use that number to calculate. So that's why it's important to know how to do this. So that's our coterminal angle. Let's try another one. Okay, so we have negative 75 degrees. And again, the directions say find the angle of least positive measure. So if you have a negative angle to start out with, then hopefully your brain is saying, well, wait, if I subtract 360, then it's just going to get more negative. So if I subtract 360 from this, then it would be negative something else. So what you're going to have to do instead is you're going to have to add 360. You'll notice I'm always doing 360, either add it or subtract it. Okay, so go ahead and go to your calculator and type. So you'll see I typed it in here, and when I type in the negative 75 plus 360, I get 285. And that's where I can stop because that's the smallest positive measure that I get. So 285 degrees. Okay, let's go ahead and try another one. So our next one is negative 800. So we're looking for an angle of least positive measure, starting with an angle that's negative 800. And again, the reason you need this skill is because if you need to graph this or calculate with it, you need to have a manageable angle to deal with. So I'm going to start by adding 360. And I'm going to keep doing that until I get a positive answer. So my first attempt, I get a negative 440. Okay, not good enough. I want it to be a positive answer. So I'm going to try again, and I'm going to add 360 again. Okay, I'm still looking at a negative number. I'm going to write this down over here so that I know what's going on. So I added 360 again, and I still ended up with negative 80. Okay, so again, the directions are saying give your least positive measure. So I need to add again. And there you go. You could see that a coterminal angle would be 280 degrees. You don't need to draw this diagram, but just to demonstrate what this is all talking about, a 280 degrees starts at this initial side and it rotates counterclockwise 90, 180, 270, and then just barely past would be 280 degrees. Okay, so that's the rotation around this way. Also, just so you're aware, if you rotate around another 360 degrees, this is also known as negative 440. And if you rotate again, it would also be known as negative 800. So these are all the same angle. It's just a different way to name it. And their names are based on how many rotations. So 280 is what we're looking for. One left to go. 23 degrees. Okay, now this is one that's kind of tricky because you're looking at it and you're like, well, wait, isn't this already the smallest positive angle? Well, it is a small positive angle, but the directions are asking you for the next smallest positive angle. So if you were to subtract 360, think about what would happen. So if I took minus 360, this would end up being a negative answer. So the directions are asking you for the next positive angle, even though it's going to be greater than 360. So don't subtract because that's going to give you a negative angle. Instead, go ahead and add. So go ahead and add these two angles together. Okay, so what I got was an angle that's 383 degrees. And you may be saying to yourself, well, wait a second, that's not under 360. It doesn't have to be under 360. It's just another name for the angle that is sitting in the same position when you are rotating around 360 degrees. All right, so this is the type of questions you're going to be doing to wrap up this last part of section 1.1. The other thing that you're going to be working on today is the review page. So you do have a quiz coming up. That will be the next thing that you're doing. And go ahead and get out that review sheet, and we're going to look at a couple of the questions. So this is number 12 on your 1.1 review worksheet. If you're wondering what to study, study the information that is on this review sheet. This is the stuff that you will see on your quiz. So I always kind of help you focus your thinking, and this review worksheet, which is posted up for you on Google Classroom, will help you to focus on what stuff you should be studying for this quiz. So let's look at number 12. It says, find the supplement of an angle whose measure is 74 degrees 39 minutes. Find the supplement. So the key word here is supplement. Hopefully you remember that supplement means that you have two angles that add up to 180 degrees. So if you know one of the angles is 74 degrees 39 minutes, you can find the other angle by subtracting. When we did this, we put in the zeros and we had to borrow. So go ahead and do the calculations on your paper. Remember, this is practicing for the quiz. If you want to pause it and try the problem and then restart it and check, then go ahead and pause now. So the difference of these two angles would be 105 degrees, 21 minutes, and then that would be letter C on your paper. Okay, so here's another interesting one. This is number 22, and you had some like this in your homework assignments. 192 revolutions per minute for a wheel. How many revolutions does it make per second? Okay, so here's what we know. 192 revolutions per minute. How many revolutions per second? So if you think about revolutions per minute, and according to the given information, it's 192 revolutions in a minute. 1 minute to be exact. The question says how many per second. So as we've been working with these conversions of units, you can really just cross out the minutes and replace it with its equivalent amount of seconds. So there are 60 seconds in a minute. So go ahead and divide the 192 divided by 60, and you will get the decimal answer, and you'll be picking from the multiple choice solutions there. So go ahead and divide and write down what you got. So I got 3.2 revolutions per second. Okay, and then if you match that up with the paper, that would be letter D. So that's your goal for these next couple days. You're going to finish any outstanding assignments, any assignments that you have not turned in, uploaded, etc. You're going to do the review sheet. So your review sheet, which is on Google Classroom. If you don't have a hard copy of this, it's on Google Classroom, so you can load that. If you want to print it out, you can and write on it. So you're going to work on that. That will help you study. And then make sure you've turned in all of the assignments as needed, and then study your information for the first quiz. The first quiz will be only covering section 1.1. Have a nice day.